Welcome back to another video. In this one we will cover the fifth question from the 2023 MIT Integration B qualifying exam. We have the definite integral from 0 to 4 of x choose 5 dx. Now if you don't recognize the integrand in which I said x choose 5, I will define that notation for you. So we sometimes use this notation, especially when we are expanding binomials. So we have this really big parentheses, and then we have some letter or variable on top, and I will write a, and then we have another one on the bottom, which I will write b, and then closed parentheses. And what this is this is the binomial coefficient. The binomial coefficient. And this is a very succinct way of writing the coefficients for our binomials whenever we expand them. For example, if you wanted to expand some really big binomial like 1 plus x to the 7th, then you could use this notation to write it really succinctly. Now, I'll cover that in another video. For this video, it will be sufficient to just know what this notation stands for, and what this stands for is another way of writing this in its factorial form. This is equivalent to a factorial over a minus b, and then that factorial times b factorial. So just as an example, if we had, say, 6 choose 3, then what that would be is that would say, okay, well, this is going to be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, and that would be over, well, what is a minus b here? Well, it's 6 minus 3, so that would be 3 factorial, so 3 times 2 times 1, and then that would be multiplied by, well, 3 factorial again, so 3 times 2 times 1, and then we could notice that, well, these 3 right here can cancel out, and we can cancel those out, and what we have left with is we have 6 times 5 times 4 over 3 times 2 times 1. And this would be 6 choose 3. So if we look at our integral on the left-hand side, we can expand x choose 5. So we have x choose 5. And well, this is going to equal, on the top we'll have x factorial, so we'll start writing some terms. So that'd be x times x minus 1, and then times x minus 2, times x minus 3, times x minus 4. And the question here is, where do we stop? Because if this were some number, if x were the number 10, then we would do 10 times 9 times 8 all the way down to 1. But since x isn't explicitly stated, we may be curious as to where to stop. So the answer will come once we do the denominator, but I will write just a couple of more terms just to make this make sense, and ... So now when we go to do the denominator, we will have to do, well, if we look at our formula here, that would be a minus b factorial. Here a minus b is x minus 5, so then we would have x minus 5, and then, well, x minus 6, and on and on and on. Well, if you notice on the top, and I will underline that in light blue, we had an x minus 5 times an x minus 6, and then we continued on and on forever. And on the bottom we have this x minus 5 and this x minus 6, and then we're going to continue on and on forever. So really what happens is the factorial on top eventually catches up to the factorial on the bottom. And then once they catch each other, we can actually just cancel all of those terms out. So the factorial in the denominator just basically serves to terminate at some point the factorial in the numerator. So we'll cancel out these terms. It will terminate at x minus 4 in the numerator. And now we have to finish our denominator with our b factorial. In this case, b is equal to 5. So this will be 5 factorial. So we can rewrite our integral. We have 1 over 5 factorial times the integral of, and this is from 0 to 4, of x times x minus 1 times x minus 2 times x minus 3 times x minus 4 dx. Now, the really clever part about this integral is a way that we can convert this using a u substitution. So what we're going to do is we're going to say, okay, let our u equal the middle term. As you notice, there are 5 terms in this integrand, and we'll let it equal the middle one. Because what we notice is actually this term, just to the right, all we did was we subtracted 1. And then this term, 2 to the right, we subtracted 2. And then if we move one term to the left, we added 1. And then if we move 2 terms to the left, then we added 2. So it would actually make sense probably to write this using a u substitution, where our x minus 2 is the simple one written as u, and then the other terms that are being multiplied by that are just either u plus 1 or u plus 2, or on the other hand, u minus 1 or u minus 2. So we can do that. And if that didn't make sense, I will show you what I mean. So if we say u equals x minus 2, then our du would equal dx. And now we are going to have to solve for our x to be able to replace that in terms of u, so our x here will equal u plus 2. Now we're also going to need to change our bounds of integration. So our upper bound, so u, and I will say b, and b is denoting our upper bound, so this will equal, 4 minus 2, which equals 2. And our lower bound will equal 0 minus 2, and this will equal negative 2. So now we can rewrite our integral. We still have 1 over 5 factorial, and this will be times, well, we have negative 2 to 2. Our x becomes u plus 2. Our x minus 1 becomes u plus 1. And then this will be times u, and then this will be times u minus 1, and then u minus 2 du. So now we've written this in a way where our middle term now looks like it's the middle, and the other terms are being expressed as plus 1s or plus 2s or minus 1s or minus 2s of whatever that middle function is. Now, before we go ahead and expand this, let's just look at what is going on here. We're taking an integral from a negative value to the equivalent value, but only positive. So what we're doing is we're taking the integral from some value, and let's say negative a to a of some function f of u du. And what we know is that if f of u is odd, if this is an odd function, then our f of u will equal minus f of negative u. That's the definition of an odd function. And what this looks like if we were to graph it would mean that if we had some input, let's say b, and then on the other side we had negative b, then our function, if it was some value, let's say this was f of b, so this is f of b, right here, then on the other side, at negative b, it would equal f of negative b. So f of negative b. And then we have this right here. So our function would end up looking something like this. This is for our odd functions. And what is special about these functions is if we integrate from negative b to b, then visually, first off, we can see that if we were to compute this area as an integral, then we would have the negative area on the left-hand side, and it would cancel out with the area on the positive side. So then the integral from minus, and I'll write minus b to b now, of f of u du just equals 0, and that's a property of odd functions. So if we can prove that our function, our integrand, is odd, then we wouldn't even necessarily need to compute the integral, because we would know that the answer is equal to 0, because we're integrating from negative 2 to 2. So in order to show that this function is odd, we need to show that f of u is equal to minus f of negative u. So to do that, we can, on the left-hand side, write u plus 2, then u plus 1 times u minus 1 times u minus 2. And now, well, we'll have our negative 1 out front, and then this will be multiplied by f of minus u. So now we will say, okay, well, this is a minus u plus 2, and then minus u plus 1, and then minus u minus 1, and then minus u minus 2. So let's take this negative 1 and let's distribute this to the middle u. So then we would get negative u plus 2 times negative u plus 1 times u, and then times, well, we can pull a negative out of this, and then we get u plus 1. We can pull out a negative out of this, and then we get a u plus 2. Now these two negative ones cancel, and we're almost done. So now we have well, I'll bring the last terms to the front, and we will get this, and then times u. And now what happens if we pull a negative out of each one of these? And we'll get a negative 1 times, well, that will just be that'll be a u minus 2, and then a negative 1 times a u minus 1. If we cancel these out and rewrite it, then what we get is u plus 2, u plus 1 times u minus 1, and I'm changing the order here, and then minus 2. So what we just showed is that our f of u, this is f of u, was equal to our minus f of negative u, which means that this is indeed an odd function. And since we are taking the integral from negative 2 to 2 of an odd function, it doesn't even matter that we're multiplying by this constant, because a constant times 0 is still 0. We can deduce that the answer to this is 0. Well, that was a very interesting problem. I hope you found it helpful. If you have any questions, please leave a comment below, and I will see you in the next video.